Welcome back, and today's video is a past exam question involving implicit differentiation. If you haven't seen my tutorial on this, please click the tab above or look at the link in the description. It involves an exponent and obviously an implicit relation, and it's 7 marks, so we should be able to do this in 7 minutes or less. Okay, start the clock. So we have an equation in terms of x and y, and it says show that the derivative of that is equal to the following. Okay, so we have to differentiate both sides of this with respect to x, so therefore this needs to be done independently to this on the right, so that'd be x cubed plus y, right? And if we're differentiating an exponent, this thing will stay exactly the same to begin with, right? But then we have to times through by the derivative of the exponent, which is actually the 2, and then we have to times by dy by dx. That was part of the chain rule that was explained in my tutorial video. And therefore then on the right, when we're differentiating these with respect to x, this first expression will just come out to be 3x squared, and the second expression there will be y will be 1. Okay, derivative of y will just become 1, but then we have to have dy by dx. Okay, now in all of these implicit questions, you have to get dy by dx together. So what we'll do is we will have 2e to the 2y dy by dx minus dy by dx, because we're moving this thing over here to the left, and then that is equal to 3x squared. Right, now we're going to factorize out the dy by dx, so we've got dy by dx, open brackets, 2e2y minus 1, close brackets, is equal to 3x squared. And on this final line here, I'm going to divide through by the parentheses there, so that will leave us with dx dy is equal to 3x squared over 2e2y minus 1. And that was what the result that they were trying to find. Now let's go back and have a look at part B. So the tangent to C at point P is parallel to the y-axis, right? So when something is parallel to the y-axis, it means it's vertical. Find the coordinates of this point P. So on this curve, there is a point on the curve basically that is parallel, like the tangent is parallel to the y-axis. So we don't know where that is, but that's what they're trying to find. So if we take the derivative expression here, which is dy by dx is equal to 3x squared over 2e2y minus 1, the way that you would get a vertical gradient is if the denominator is equal to 0, because then you'll get an undefined point. That basically means a vertical line. So therefore then, when the denominator is equal to 0, we would get the undefined point. So therefore we're going to equate this thing to 0, right? And if we move, we could solve this exactly. We move the 1 to the left, and we divide by 2. And now we need to get y, the subject. So this is a law of logs. I'll just quickly do it over here. If we take a natural log of e, so like this, what you're really saying in is log to base e of e to the 2y. So you're saying, what do we raise the power e by in order to get e to the 2y? Well, that result is just 2y. In other words, it cancels out. So therefore, if you're taking natural logs of both sides, you would get that. And natural log of the right-hand side then just breaks down to 2y. And now we're going to times both sides by a half. So a half natural log of 1/2 is equal to y. And that is my answer. So y is equal to that value. Now, that is only one part of the coordinate. So we've just found that that is equal to half natural log half, right? That's the y coordinate, but we need to now find the x coordinate. So what I'll do is I'll have to substitute that in to the original expression up here to find what x is. Okay, so paste that down. Take the e to the 2y is equal to x cubed plus y, and we need to now find the value of x. So we're going to substitute this value that we just found it in for y into here. So we have e to the 2, and we need to put that in now. Natural log half there is equal to x cubed, and then plus this half natural log half there. Now we can times these 2 and this half together. That will just result in 1. And then we have this inverse function. So e to the natural log of a half, in the same way that it cancelled down in the previous section of this question, this would also then just cancel down to be a half. Like it's almost as a cancel out. Now there are many proofs online to why that is the case, but I won't go through the proof right now in this exam question. And then we have half natural log 1/2. We're going to move this expression here to the left. So now we have a half minus a half natural log half is equal to x cubed. Now we're going to cube root both sides. But before I do that, I'll just take out a factor of a half here, because that can just be 1 minus natural log half is equal to x cubed. And I will take the cube root of both sides. So when I take the cube root of the right hand side, that will cancel with the cube. But when I take the cube root of the left hand side, that will be to the power of 1/3. So my final answer there is x. So we have a half, open brackets, 1 minus natural log half, close brackets, and that is all raised to the power of 1/3. So we found an exact coordinate. That is the end of that question. Let me know how you get on in the comments below. Don't forget to like and subscribe to the channel. See you next time.